All right, section 3.1, we're going to be talking about graphing quadratic functions. We have talked about quadratic functions briefly in the graphs of them when we were talking about line symmetry. Excuse me. But this whole chapter is devoted to quadratics, quadratic functions, quadratic equations, different ways to solve quadratic equations. We're going to start off just by talking about graphing quadratic functions and analyzing them. Okay, so I'm going to start off talking about what does a quadratic function look like? What is the format of a quadratic function? So they all look like this, and in this, a can't be 0. Okay, so they take the form ax squared plus bx plus c. A can't be 0. B and c can be 0. It's fine. It's still a quadratic. All right. So a, b, and c are just real numbers. Okay, so 7, 28, 1/5, something like that. Usually they're rational numbers. Okay, to make a quadratic function. This term here, the term with the x squared in it, is called the quadratic term. This term here is called the linear term. Linear because it's x to the 1 power. All right, and then this c here, this is called the constant term because that is just a constant, just a number. So like 7, 8, -18, numbers like that, okay? The graph of a quadratic is a parabola, all right? So when you graph a quadratic function, you should get a parabola. If you don't, you're not graphing a quadratic. All right, so there's these functions could take all different forms. Maybe you have something like -2x squared minus x plus 12, all right? And then this a would be -2, a b would be -1, and c would be 12. Maybe you have something like this. 4x squared plus 19. That would be a quadratic function. And then in this one, b would be 0. A would be 4 and c would be 19. You could also have something like this, where c is 0. So maybe you have -4x squared minus 12x, and that's it. Okay, those would all be quadratic functions. They will all graph parabolas. All right, so let's start by graphing. Now I'm going to show you how to graph with both the graphing calculator and in Desmos. I think you'll find that Desmos is a little bit nicer for most things. It's at least fewer clicks usually. But either one will work. So we want to graph this function using a table. What we're going to do is type these functions into the graphing calculator or into Desmos, and this is what we've got. I've already plugged it in here into the graphing calculator. Take a look at the graph. Now, one way to graph this is using the trace feature. The problem with the trace feature is you'll see, so sometimes you get a nice point, but a lot of the points are pretty ugly. All right, so if you go to your table, though, you should have several points there that you can plot. Okay, so for instance, we've got 0, 6. I can plot that point. I see that I've got -1, 1, -3. So 1, -3 would be like here. And then I've got 3, -3. So over 3, down 3, like that. And then you can see that, what else have we got here? One more. So 4, 6. So over 4, up 6. And you can see that the minimum is going to be at 2, -6. I skipped over that point for some reason. Okay, so we have a minimum right there, and the graph goes something like this. Okay, should be more of a parabola than what it looks like there. Here's the graph in Desmos. So if you're trying to graph this in Desmos, remember, I think we talked about this in a different video, but if you hit the little gear and you hit the little table, it'll automatically turn it into a table. And if you want other values, you can just type in the values, and it will give you the points, okay? And so you can see the points being plotted there. It's quite easy from there to plot those points that you need on the graph and get a nice sketch of the function. Okay, so let's get rid of that. All right, next, let's talk about the structures of the parabola, okay? There's different parts of the parabola, and you need to know all the different, kind of the main features of them, okay? So, this is going to be annoying if I don't move it. All right, so you can consider the graph of y equals ax squared plus bx plus c, where a doesn't equal 0, so you got a quadratic function. The y-intercept, remember that's when x is 0. So if you plug in 0 for x, you'll get the y-intercept. When you do that for a quadratic, everything goes to 0 except for c. So it turns out that this c value right here, this number, at the end of the quadratic, that's your y-intercept. Don't even need to graph it. Just look at the function. That'll give you your y-intercept. right? The equation of the axis of symmetry. So what is the axis of symmetry? That is, if you remember when we talked about line symmetry, that is the axis of symmetry in a parabola, okay? So you can see in the picture here. And again, you don't even need to graph it to get the axis of symmetry. You can just compute it by taking negative b over 2a. Now, lots of times it's going to be easiest just to graph it, but there's a little formula for the axis of symmetry. The x-coordinate of the vertex, we'll actually back up a second. The vertex is that point there that is either the maximum or the minimum, all right? The x-coordinate of that vertex is the same as the axis of symmetry, as you can see. That will be the x-coordinate right here. Okay, so you can see here we've got the y-intercept and yeah, then the reflect. Okay, so we don't care about that so much. All right, so that's the structure of the parabola. What we're going to do in the next problem is try and find all of that stuff. All right, so consider the graph of f of x plus equals x squared plus 4x minus 3. We want to find the y-intercept. We want to find the equation of the axis of symmetry. I'm just going to write axis. Then we want to find the x-coordinate of the vertex. So I'll just write x-coordinate. Okay, we want to find all of those things. So here is the easiest way to do that. Well, actually, you don't even need the calculator, but ultimately we want to graph it. So we'll go to the calculator for that. But the y-intercept is this number out here. It's -3. It's always that last number, the c value. So that's at y equals -3. Or you could write 0, -3. That would be fine too. The axis of symmetry, we can compute that over here, negative b over 2a. So that would be x equals -4 divided by 2a, which would be 2 times 1. So it's going to be -2. But I think we should just take a look at the graph real quick. I have it already typed into Desmos here. So this is what the graph looks like. And you can see that it's pretty easy to find where the axis of symmetry will be. It will be at x equals -2 once you've got the graph. That also will be the x-coordinate of the vertex. Those are the same. The axis of symmetry would be right here, and the x-coordinate of the vertex is -2. Those are intimately connected. Okay, so let's graph this thing. So it looks like I've got -2, -7 on the graph as my vertex. So I'll plot that. I'm going to sketch in the axis of symmetry as a dotted line here. Another way to graph this is not to just go from the table of points, but to plot using a 1 point on each side. So for instance, if you know that this point, well, that's not a good point. That's a good one. So for instance, up here, we know that 2, if you guys can see this or not, probably just easier to go with the table, I guess. But 2, 9 is on there. So 2, 9. And then so if you go over 4 units this way, we've got a y value of 9. If you go 4 units back this way, you'll also have a y value of 9. So you can plot the graph in that way as well. This graph wasn't exactly beautiful for that. So, but it turned out the table of values was easier anyway. But that's how you can graph using the axis of symmetry. If you get 1 point on one side, you just mirror that to the other side, and you get the graph in that way. Okay. If you go to use this do this in the graphing calculator, which you can do. So let's see, we have just x squared plus 4x minus 3. You hit graph, and again, you can just go to your table of values. And actually, I will show you a way to get this point down here if it's not a nice point. But if you go to your table of values, you can get the points that you need there. And so when x is 0, for example, that gives you your y-intercept, which was -3. The axis of symmetry you can get from the graph. But I'll show you an easy way to do that when we get to number 3 in your calculator. All right, let's talk about maximum and minimum values. We've already talked about maximums and minimums before. So we've already talked about maximums and minimums and in the context of other problems, but every parabola will have a max or a min, and that will depend on the a value out in front. So if a is positive, so you have something like this function here, 4x squared plus 19, that parabola will open up, so it will have a minimum. If a is negative, so if a is less than 0, then the parabola will open down. Okay, so if you had a function like this one, negative 4x squared minus 12x, then the parabola will open down, and therefore it will have a maximum. Okay, you can always graph it too just to check, but you can also get that right from just looking at it. So in number 3 here it says, consider this function, determine whether it has a max or min, then state it, and find the domain and range. So we'll do all of that, but right away we can see that this has a negative a value, which means it'll take the shape of this. It'll be a parabola that opens down, therefore it will have a maximum. So we can write right away, without even graphing anything, that it has a maximum. And then it says determine the maximum or minimum value. The maximum or minimum value is the max or the min of that point. I'm sorry, the y value of the point. So if you look, here's the graph. You can see, so we've got the maximum there at 27. Okay, that's what they're actually looking for, but I'm really okay if you just put the whole point, 1.5 comma 27. That's where your maximum is. It bakes in the maximum value there too, so that should be fine. All right, so we know what the graph looks like, is a max or a min. Then then domain and range. So we need to find the domain and range. It is a parabola, and domain is all of the x values covered by the graph. It will go forever left and right. So the domain is all real numbers because the graph goes, the more you zoom out, doesn't matter how far you zoom out, all x values will be covered by this graph eventually. That is not true for the y values. So as you can see here, the y values stop here. So if you imagine, you ask yourself, is negative 15 in the range? Yeah, it is. There's graph there. There's graph, 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 all the way until you get to 27, and then the graph stops. So it's, for the range, it's everything less than, so y less than or equal to 27. And what I want to do is show you this in the graphing calculator because it does look a little bit different. If you plug in negative 4x squared plus 12x plus 18, and you hit graph, you'll notice in the standard window you can't see the maximum. Now one way around this is to zoom out, but I hate zooming out because it is it's like a sledgehammer, using a sledgehammer for everything. Sometimes it's the perfect tool. Most of the time though, you're going to do more damage than what you need to. So let's change the window. What we want to do is look higher on the graph. And you can do this in Desmos too. You don't just need to use the zoom feature. We want to look higher on the y-axis. So I'm going to hit window, and I'm going to change my y maximum to, I don't know, let's start with 50. Right? Just pick a big number that might encapsulate the maximum value. That happened to work. If it didn't, we'd go back to window, and we change the y max to 100 or 200. It just depends on the problem. So now you want to find that maximum. You're going to hit second calc. So second and the trace key. So second calc, maximum. And then it says pick a left bound. That means pick a point to the left of the maximum. So clearly there I'm to the left of it. Hit enter. Then it says right bound. So pick a point to the right. Hit enter. Then it says take a guess. So then you get sort of close to the maximum. Hit enter and it will tell you where that maximum value is. So 1.5 comma 27. Ignore the rounding error here at the end. So 1.527 is where the maximum is. So you can do it in your graphing calculator, you can do it in Desmos. It doesn't matter either way. Either calculator will work just fine. And I think that wraps up everything for graphing quadratic functions.